Hello, everyone. Welcome back to Pre-Algebra, Chapter 4, Lesson 9. 4.9, Multiple Operations, or Solving Equations with More Than One Operation. So today, we are going to learn how to solve equations for variables that have not just addition, not just subtraction, not just multiplication, and not just division, but they have some combination of the four of these. Let me give you an example. Let's say I have an equation that looks like this. 3x minus 5 is equal to 16. Now, this is something we haven't seen before. Usually, we either see just the multiplication or just the subtraction, and then we have to find the variable. But today, we are having equations that have multiple situations. First, it's good to understand what this is saying. What this is saying is that if you multiply 3 by whatever this number x is, and then you subtract that difference or that answer by 5, you will end up at 16, right? So essentially what you could do is you could go backwards and say, what is 16 plus 5? And then whatever that answer is, you need to divide by 3 to get what that is. But that's too complicated for us today. So what we're going to do is we're going to do it step by step, and we're going to reverse engineer this problem. So we all know that we're trying to find this variable, right? The variable x. What is that worth? Here's how I would do it. I would start with addition or subtraction and try to undo those, right? So do I have addition or subtraction here? It's almost like reverse PEMDAS. I have subtraction, so what I'm going to do is the inverse of subtraction, which is addition. So I'm going to first start off by, you know what I'm going to do? I'm going to do every one of the inverses in red so you can see what we're doing. So I'm going to add 5 to both sides. I'm going to try to get rid of that negative 5 or that minus 5. What I do to one side, I must always do to the other, and the other side of the equal sign to keep balance. And so I'm going to rewrite this equation. 3x, nothing happened to this one, right? Nothing happened to the 3x, or the 3 times x. Negative 5 plus 5 zeroes out, right? Becomes 0, so we can just say that cancels out. Nothing happened to the equal sign, so we can just drop that. Now, what is 16 plus 5? Well, 16 plus 5 is 21, so I can write 21 right here. So now my new equation says, what is 3 times x equals 21? What times 3 equals 21? So now I notice that I have multiplication, right? Because 3x is really 3 times x. So now I'm going to use division to get rid of the 3. So I'm going to divide by 3. 3 divided by 3 is 1, so these cancel each other out. These negate. 21 divided by 3, what I do to one side, I must do to the other. 21 divided by 3 is 7. So now I have 7 over here. 3 divided by 3 was 1, so that's 1 times x equals 7. But 1 times anything is that thing, so this is just going to end up being x. X is equal to 7, right? Now that the variable is isolated by itself, I'm going to test it. I'm going to prove. So how do I prove it? We all know this now. First, I rewrite the original equation. 3 times x minus 5 is equal to 16. Then I'm going to use substitution, and I'm going to replace the x with the 7. So I'm going to go 3 multiplied by 7 minus 5 is equal to 16. Then I'm going to use PEMDAS. Do I have parentheses? No. Exponents? No. Multiplication? Yes. I have the 3 multiplied by the 7. 7 times 3 is 21. I rewrite the equation to make it look clean. All right, then I finish up PEMDAS. Do I have division? No. Addition? No. Subtraction? Yes. I have 21 minus 5. 21 minus 5 is 16. 16 equals 16 on both sides. Yes, ma'am. Yes, sir. Does that work? My equations are balanced. Therefore, x does equal 7. My answer is x is equal to 7. And that's it. Pretty simple. So what we did is we first undid addition or subtraction. Then we undid the multiplication or division by using the inverse. And then we plugged it back in using substitution to prove our answer. And our answer is x is equal to 7. So now let's write down a formal process for doing that. I would like you to write this in your notes. So here's how you do it. Step 1. You're going to rewrite original equation. All right, so let's try this next problem. Ooh, here's a good one. This is a division problem. The original equation is 20 is equal to some number y divided by 2 plus 4. So now that we've rewritten the original equation, we go on to step 2. Step 2, undo addition or subtraction. So now I have to look. Do I have addition or subtraction anywhere in my original equation? Ah, yes, I do. It's the plus 4. It's addition, right? So how do you do addition? You subtract. I subtract a 4 from this side. What I do to one side, I must do to the other. All right. Now I clean it up. Step 3 is to solve or clean it up. Clean it up. 20 minus 4. What is 20 minus 4? 20 minus 4 is 16. Did anything happen to the y divided by 2? No, so we just rewrite that. Y divided by 2. 4 minus 4 is 0. So I don't even really need to write a 0 because that's just a waste of space. So now I have 16 equals some number divided by 2. Well, some of you could figure out what that answer is going to be, but for the rest of us, let's keep going. Step 4, undo division or multiplication. All right, do I have multiplication here? No. Do I have division here? Yes. So if I have division, y divided by 2, what do I need to use to get rid of the division? Well, I need multiplication. So I'm going to rewrite the problem so I have more space. Y divided by 2 can be rewritten as y divided by 2. So in this way, what I can do is I can use multiplication like that. What I do to one side, I can do to the other. And that just represents what I'm doing. Step 5 would be to solve and clean it up again. 16 times 2 is 32, I believe. Yes, 32. There's a lot of pressure to do this while you're being recorded. Y, nothing happened to it. Divided by 2 times 2 is the same thing as saying nothing, right? It cancels each other out. So 32 equals y, right? Well, it's not really nothing, but it is 1. But essentially, it's going to be y times 1, and that's just going to turn into a y. So 32 is equal to y. Now, we have to prove it, right? So I'm going to do step 6, which is prove it. All right, we're saying that 32 is equal to y, right? So to save space, I'm just going to replace the y with 32. And then we're going to use PEMDAS to try to solve this, right? Up here at the top. Let's see if it works. All right, step 1, PEMDAS. Do I have any parentheses? No. Oh, how about this? Let's write this down here. Let's prove it. Use PEMDAS. There we go. So that's a good little note for you. All right. Do I have parentheses? No. Exponents? No. Multiplication? No. Division? Yes. Where's the division? It's the 32 divided by 2. So I rewrite the equation. 20 equals 32 divided by 2, which is 16. Then I rewrite the 4 plus 4. All right. Do I have addition? Yes. Yes, I do. And no subtraction. So just addition. I have the 16 plus the 4. 16 plus 4 is 20. Rewrite it. Does 20 equal 20, ladies and gentlemen, and variations thereupon? Yes, it does. Therefore, my equation is balanced. What's on one side of the equation is now equal to what's on the other side. I use PEMDAS. Everything is good. 32 does, in fact, equal y. There we go. That's it. It's pretty simple, right? Let's try another problem. I'm going to leave the steps up there so I don't have to keep rewriting them. Oh, sorry. All right, here we go. Let's try it again. Let's say I have this problem. And the problem, oh, it's much simpler. It says 4z, I'll rewrite this in color. 4 times z plus 3 is equal to 23. All right, let's go through our steps. Number 1, rewrite the equation. Did we do that? Yes. Step 2, undo addition or subtraction. Okay, do I have addition or subtraction? I have addition. Let me rewrite that cleaner so it looks good. There you go. I have addition, so I need to use the inverse of addition, which is subtraction. So instead of plus 3, I subtract 3 from this side, and I subtract 3 from that side. I clean it up, step 3, and I should get nothing happened to the 4z, so it should still be 4z. 3 minus 3 is 0, so I can write nothing there. I don't have to, they just go away. 23 minus 3 is 20. All right, now I've done that, I've cleaned it up. Now I have to undo division or multiplication. Do I have division here? No. Do I have multiplication? Yes. Where? It's the 4z. It's really 4 times z. So how do I get rid of this 4 so the z can be by itself? Since I multiplied by 4, I now need to divide by 4. What I do to one side, I do to the other. 4 divided by 4 is 1. So this is going to turn into 1 times z equals 20 divided by 4, which is 5, right? 1 times z, 1 times anything, we're cleaning it up right now, is itself. So z is equal to 5. Now all I have to do, I've done this, now all I have to do is prove it. So I'm going to rewrite the original equation down here. 4z plus 3 is equal to 23. This is the original equation. All I need to do is substitute the z for 5, or 5 for z, however you want to say it. 4 times 5 plus 3 equals 23. Is that true? Let's use PEMDAS. Parentheses, none. Exponents, none. Multiplication, yes. 4 times 5 is 20. 20 plus 3. Any division? No. Any addition? Yes. Where? The 20 plus the 3. 20 plus 3 is 23. Oops, sorry, I'm running out of space down there. Does 23 equal 23 on both sides? Yes, it does. Yes, it does. It checks out. Ladies and gentlemen, Z does equal 5. There's your answer. Yay, we did it. All right, let's do one more so that we can say we've done a nice clean 3. We did addition, we did subtraction. Let's do a subtraction problem. One more. Here's a good one. All right. Hopefully these are becoming easier for you as we've been doing them. You should start to understand why knowing your math facts is so important in algebra. It makes everything so much faster and easier. And understanding the rules of division cleans it up very nicely, wouldn't you say? All right, let's try this last one out. All right, my problem is I've got 16, and it is equal to 2 times some number called b, and we're going to take away 8 from it. What is b worth? First step, rewrite the equation. Let's do it. 16 equals 2 times b minus 8. Step 2, undo addition or subtraction. I have subtraction, so I'm going to rewrite the equation and undo it. The opposite of negative 8 is positive 8. What I do to one side of the equation, I must do to the other. All right. Let's clean it up. 16 plus 8 is what? 20. Let's try it out. Oops, I was about to drop that. Whoops. 16 plus 8, right? 6 and 6 is 12, so 22, 22 and another 2, 24. So I have 24 here equals 2 times b, because nothing happened to it. Negative 8 plus 8 is 0, right? Cancel each other out. We've cleaned it up. Now we move on to division or multiplication. I have multiplication, the 2 times b. How do I undo or get rid of multiplication? Well, I do the inverse, which is division. So I'm going to divide by 2 here. I'm going to divide by 2 there. 2 divided by 2 is 1, so the new equation looks like 24 divided by 2, which is 12. So I'm going to have 1 times b. 1 times b is b. 12, I've undone it. I've solved it. 12 is equal to b. Now I have to prove it. All right, let's go in. I rewrite the equation. 16 equals 2b minus 8. I substitute the b for 8. 16 equals 2 times, I'm sorry, 12, not 8. 12, 12, 12. What am I doing? Oh my gosh. There we go. Okay. Now I use PEMDAS, right? Do I have parentheses? No. Exponents? Nay. Multiplication? Yay. 2 times 12. 2 times 12 is 24. I rewrite the equation, make it clean. 16 equals 24 minus 8. Do I have division? No. Addition? No. Subtraction? Yes. 24 minus 8 on this side is 16. 16 on this side is 16. We are good. Ladies and gentlemen, the answer is indeed 12 is equal to B. So now you should see how PEMDAS is applied to these problems. Going backwards helps you solve for a missing variable. how substitution helps us to test whether or not the variable is actually what we say it is, and how to use the inverses of each operation to try to solve a problem. I hope this video helped. If you have any questions, please let me know. But until next time, stay classy.